Hi everyone, today we'll be looking at the Pure Mathematics 1 January 2021 paper. Question 1, we've got a curve with this equation here and we need to find in its simplest form dy dx. So I will actually start off by writing y in a form that allows differentiation to take place without any mistakes. So this is minus 3 over 2x to the minus 1 plus 7. Now in differentiation we take the power down and we deduct 1 from the power, so that's going to be 6x squared minus 10x plus 3 over 2x to the minus 2, and that's part A. And then in part B we've got the point P on the curve having an x coordinate of a half, and we need to find the equation of the normal to the curve at this point, giving our answer in the form ax plus by plus c is 0. So I will actually start off by saying that when x is a half, I will find the value of y by substituting in the expression for y. So y will be 2 times a half cubed minus 5 times a half squared minus 3 over 2 times a half plus 7, and this is giving an answer of 3. I will also find the gradient of the curve at this particular point by evaluating dy dx at x is a half. So that's going to be 6 times a half squared minus 10 times a half plus 3 over 2 times a half to the minus 2. And this is giving an answer of 5 over 2. I have been asked to find the equation of the normal. So to find the gradient of the normal, I will flip and change the sign of the gradient of the tangent. I'm using the fact that two lines are perpendicular if the product of their gradient is -1. So I now have the point, this is the x, this is the y, and the gradient. So y minus y1 is mx minus x1, which means that y So I now have the point x, the y, I have the gradient of the line, so I'll be using y minus y1 is mx minus x1, so y minus 3 is minus 2 over 5 brackets x minus a half. I could actually start off by cross multiplying by 5, so that's going to be 5y minus 15 is equal to minus 2x plus 1, and therefore 5y plus 2x minus 16 is 0, which is the answer in the required form. In question 2, it's a tree that was planted. Well, 3 years after planted, the height was 2 meters, and 5 years after it was planted, it reached a height of 2.4 meters. We believe that this is a suitable model to describe the relationship between the time and the height, and we need to find to 3SF where necessary the values of P and Q. So I will start off by saying that we have been told that when T is 3, H is 2, which means I can substitute to get 2 cubed is P times 3 squared plus Q, which means that 8 is 9P plus Q. We also know that when T is 5, H is 2.4, which means that 2.4 cubed is P times 5 squared plus Q, and therefore 13.824 is 25P plus Q. We're essentially looking at simultaneous equations here. I'm going to label the first one as 1, the second one as 2, and therefore if I do 2 minus 1, I will get that 5.824 is equal to 16p. I will divide by 16, and this will give me the value for p. It turns out that p is 0.364. And then I will substitute back into 1 to find the value of Q. So 8 is 9 times 0.364 plus q, which means that we've got 8 to be 3.276 plus q, which makes q 4.724. I have been asked to give answers to 3SF, so I'm going to round this to 4.72. I was part A. Now, exactly capital T years after the tree was planted, the height was 5 meters. We need to find the value of capital T. So, in other words, we know that when small t is capital T, capital H is 5, and therefore 5 cubed is equal to 0.364, the value of P we found, times T squared, plus 4.724, the value of Q we found. So 125, the 5 cubed, minus 4.724 is 0.364 T squared. So 120.276, I will divide this by 0.364. And then I will take the square root to find the value of T. I'm not going to bother with the negative square root because T is time, and therefore there is no negative value for capital T. And it turns out that T is 18.2 years. In question 3, we're being given a sketch of a part of the curve with equation y is 4 cos x. And we need to state the coordinates of P and the coordinates of Q. Well, first of all, we need to consider what the 4 is doing there. It's a stretch along the vertical scale factor of 4. So it means that all the y values get multiplied by 4. We know that the cosine of x has a maximum at 1 and a minimum at -1. So the maxima now go to 4 and the minima go to -4. I also know that the cuts were originally at 90, 270, and then every 180 degrees. So the next one is here at 450. So I have actually just found the coordinates of Q. And if I move on to the negative x-axis, this is minus 90, this is minus 270, and halfway in between at minus 180, it's the x-coordinate of P, and the y value is -4 because of the stretching by a scale factor of 4, and therefore P will have coordinates of minus 180 degrees, comma -4, and Q has coordinates of 450, comma 0. Now we've got the second equation. The curve C2 has equation y is 4 cos x plus k, where k is a constant, and the curve C2 has a minimum y value of -1. So we know that this plus k is a translation k units up. I will actually start by considering the range of values of 4 cos x. We know that 4 cos x lies between 4 and -4. So if I add k, and I'm dealing with 4 cos x plus k, then the maximum will be 4 plus k, and the minimum will be -4 plus k. Now, the minimum is at -4 plus k, and I have been told that this minimum is -1, which means that k is equal to 3. Now, this is not the end of the story. The point R is the maximum point on C2 with the smallest positive x coordinate. It makes sense to look at the graph I was given here. The maximum was here. It was at 360,4. And actually, I have translated by 3 units up because we found k to be 3. So we've got +3. So it's going to be here at 360,7. So the coordinates of R are exactly 360,7. Question 4, we've got 2 points, P with coordinates negative 2, 13, I might as well label them here, and Q with coordinates 4, negative 5, and I need to find an equation for the line passing through P and Q. So I will start by finding the gradient of this line. So it is y2 minus y1 over x2 minus x1. So what I get is negative 5 minus 13 over 4 minus negative 2, which gives me minus 3. I'm using y minus y1 is mx minus x1. So y minus negative 5 is negative 3 brackets x minus 4. I need to give my answer in the form of y cos mx plus c. So I will expand. Y plus 5 is negative 3x plus 12. So y is negative 3x plus 7 is my answer for part A. And then the quadratic curve C passes through P and has a minimum point at Q. We need to find an equation for C. So let's consider on what we know about this quadratic equation C. Well, it has a minimum at 4, negative 5, and it also passes through minus 2, 13. So I'm gonna exploit the fact that Q is a minimum point. So this means that I could write for C the equation for y would certainly have an x minus 4 squared term and then a negative 5. I'm mimicking the completing the square structure for the quadratic because this ensures that the minimum is at 4, negative 5. The only thing we're not really sure of is whether there is a number here. I'm gonna put a k. So up to now, I have made sure that the minimum point is indeed at 4, negative 5. I'm gonna use the fact that I pass through negative 2, 13 as well. So when x is negative 2, y is 13. So 13 is k times negative 2, negative 4 squared minus 5. So 13 is k times minus 6 squared minus 5. 18 is 36k. So it turns out that k is a half. So the equation for C is y is a half brackets x minus 4 squared minus 5. And then part C, we need to determine the inequalities that define the region R. It's this region here. Well, obviously I need to be above the straight line. I need to be below the parabola. That if you just stick to these two inequalities, you should observe that this region also satisfies that it's above the straight line and below the quadratic. So in order to make sure that we're referring only to this region here, I will introduce an extra condition that x is less than or equal to negative 2. So I'm just capturing this part of the curve. So we want to be above the straight line, which means that y is greater than or equal to negative 3x plus 7. We want to be below y, below the parabola, so y is less than or equal to a half x minus 4 squared minus 5. And we also want x to be greater than or equal to negative 2. In order to make sure exactly what I referred to before, I want to capture only this region, because without the restriction of x being greater than or equal to negative 2, this region here also satisfies being above the line and below the parabola. Question 5, we've been given the plan view of a viewing platform at the tourist site. It's a sector and a triangle. Now OC and OA are radii and are 6 meters. The distance AD is 14 meters. Angle ADC is 0.43 radians. And we need to find the size of angle AOD in radians to 3 dps. I will actually use the sine rule for this one. So I will simply say that sine of 0.43 over 6 is sine of theta over 14, where theta has actually been labeled to be this angle here. So I'm gonna use the calculator. I get that 14 sine of 0.43 over 6 is equal to sine theta, and therefore theta seems to be 1.3365887. However, we've been told that angle AOD is an obtuse angle, so this angle here is obtuse. We know that 1.336 would be one possible value for theta, or pi minus that. The supplementary angle would also satisfy the sine rule. So since AOD is obtuse, we can say that AOD is pi minus 1.3365887, which to 3 dps is 1.805 radians. Now in part B, we need to find the length of the arc ABC. This is the arc ABC. Now we know that angle theta is 1.805, which means that this angle here is simply 2 pi minus 1.805. I will be using the fact that the length of the arc is r theta, since the angle is in radians. So length of arc ABC is the radius of 6 times the angle of 2 pi minus 1.0805, which is 26.9 meters. And then for part C, we need to find the total area of the viewing platform, where we've got here the sector, and then it's the triangle. So I will actually find the angle here by doing pi minus the 1.805 and the 0.43. This is giving an answer of 0.9065887, because my intention is to use the half AB sine C formula with the 6 meters and the 14 meters. I will also find the area of the sector. I know the formula, it's a half r squared theta, so I'll start with that one. So the area of the sector is a half, the radius is 6, the angle is 2 pi minus 1.805, which gives an answer of 80.607 square meters. The area of the triangle, we said I'm going to be using the half AB sine of 0.9065887, which gives 33.071 square meters, and therefore the total area will simply be the sum of these two values, which gives a final answer of 113.7 square meters. In question 6, we've been asked to sketch the curve with equation y is minus k over x, where k is positive. Now we know this belongs to the reciprocal curves, so it has asymptotes at the x-axis and the y-axis. The fact that k is positive and the negative sign in front means that it looks something like this. So this is the x-axis, the y-axis, minus k over x. And then on a separate diagram, sketch the curve with this equation, which is simply a translation k units up. So I know that the horizontal asymptote, which was originally the x-axis, has now moved by k units upwards, and it's now at y equals to k. So it will look something like this. The question is asking us to give the coordinates of the point of intersection with the x-axis in terms of k. So if I have a cut on the x-axis, that means that y is 0. So I have minus k over x plus k is 0, which means that k is k over x. So kx is k, so x is 1. So this is 1, and this is the complete sketch of the graph. Part C, we need to find the range of possible values of k for which the curve does not intersect the line with the equation y is 3x plus 4. So we are essentially looking at two equations. We've got on one hand the y is minus k over x plus k, and on the other hand the y is 3x plus 4. If I was to try and see whether they intersect, I would equate the two. So minus k over x plus k is 3x plus 4. I will multiply throughout by x. This is gradually giving me a quadratic. I'll collect everything on the right hand side. I get 3x squared plus 4x minus kx plus k. So I have 3x squared plus 4 minus k brackets x plus k. We know that if we have no intersection, that means the discriminant has to be negative, so no solutions arising from this quadratic. So the discriminant should be negative, and therefore b squared minus 4ac should be less than 0. My b is 4 minus k, my a is 3, and my c is k. So 16 minus 8k plus k squared minus 12k is less than 0, which means that k squared minus 20k plus 16 is less than 0. It's a quadratic inequality. It does not factorize. I will find the critical values by using the quadratic formula. So k is minus b plus minus b squared minus 4ac square root over 2a, which gives me 10 plus minus 2 root 21. We know that quadratic inequalities are solved graphically, so I quickly sketch a smiley parabola because it's a k squared, the coefficient is 1, and I know the critical values are at 10 plus 2 root 21 and 10 minus 2 root 21. It goes plus, minus, plus, and we want to be negative, so we want to be in between. So it's all values of k such that 10 minus 2 root 21 is less than k, which is less than 10 plus 2 root 21. This is the set of values for k for which the curve and the line do not intersect. Question 7, we need to solve f of x is 9, so f of x is 2x minus 3 root x minus 5 is equal to 9. This is actually a disguised quadratic. I will let w be root x, which means that w squared is x. So I will express this in terms of w to see the quadratic. So 2w squared minus 3w minus 14 is 0. it is crucial to realize that the moment I am letting w be root x, it means that I understand that w has to be positive because the square root of x is always positive. Now this quadratic factorizes into 2w minus 7w plus 2, which means that 2w minus 7 is 0, or w plus 2 is 0. So 2w is 7, leading to w being 7 over 2, or w being negative 2. We knew that w had to be greater than 0, so this is not a valid answer, so I reject since w is greater than 0. And then if w is 7 over 2, this means that root x is 7 over 2. So x is 7 over 2 squared, which is 49 over 4. Part B, we need to solve the equation f dash dash of x is 6. I will actually start by writing f of x in a form that allows me to do the differentiation. It's 2x minus 3x to the half minus 5. F dash of x is 2 minus 3 over 2 x to the minus a half, and f dash dash of x is 3 over 4 x to the minus 3 over 2. Remember, we are getting the power down, deducting 1 from the power, and we have been told that f dash dash of x is 6. So I will cross multiply to get 3x to the minus 3 over 2 is equal to 24, which means that x to the minus 3 over 2 is 8. Now the negative power can be dealt with by writing it as 1 over. So 1 over x to the 3 over 2 is 8, which means that x to the 3 over 2 is 1 over 8, which means that x is 1 over 8 to the power of 2 over 3. This is simply the third root of 1 over 8 raised to the power of 2, which is a half squared, which is a quarter. So the value for x satisfying f dash dash of x is 6 is a quarter. In question 8, we are being given a sketch of a part of curve C with this equation here, 3x minus 2 all squared x minus 4, and we need to deduce the values of x for which f of x is greater than 0. I will start by finding the two cuts here because they will help me identify the range of values for x. So a cut on the x-axis means that y is 0, so solving f of x is 0. Means that 3x minus 2 squared x minus 4 is 0, and therefore 3x minus 2 is 0, or x minus 4 is 0. So x is 2 over 3, or x is 4. I'll just go back to the diagram to identify the 2 points. This is 2 over 3, this is 4. We want f of x to be greater than 0, so it has to be greater than 4. So f of x greater than 0 means that x has to be greater than 4. And then in part B, we need to expand f of x to give this form here. So we have f of x to be 3x minus 2 squared x minus 4. So I will start by expanding the first bracket. It's 9x squared minus 12x plus 4 times x minus 4. A further expansion gives me 9x cubed minus 36x squared minus 12x squared plus 48x plus 4x minus 16, which gives me 9x cubed minus 48x squared plus 52x minus 16. That was part B. And then C, we've got this line L, which passes through the y-intercept of C parallel to the x-axis. So there it is, passing the y-intercept. It must be something of the form y is a number, and we have to find the distance between P and Q in the form k root 3. So we will start by finding the y-intercept here, finding the equation of the straight line, and then identifying the coordinates of P and Q to find the distance between them. So the cut on the y-axis, the y-intercept, means that x is 0. So cut on y-axis, it's going to be given by f of 0, which is obviously minus 16. And therefore the line L has equation y is minus 16. I will now equate f of x with negative 16 to find all points of intersection between the line and the curve. So 9x cubed minus 48x squared plus 52x minus 16 is minus 16. So 9x cubed minus 48x squared plus 52x is 0. I will factor out x. I've got 9x squared minus 48x plus 52. So either x is 0 or 9x squared minus 48x plus 52 is 0. This will not factorize. I will instead use the quadratic formula. So x is minus b plus minus b squared minus 4ac square root and all of it over 2a. This is giving values of 8 plus minus 2 root 3 over 3. So it is clear that P will be having coordinates 8 minus 2 root 3 over 3, comma negative 16 because it's on the left, and Q, it's going to be the positive solution 8 plus 2 root 3 over 3, comma negative 16. And therefore the distance PQ, since both these points are on the same height, is simply the difference between the x values. So it's 8 plus 2 root 3 over 3 minus 8 minus 2 root 3 over 3, and this is giving you 4 root 3 over 3 units. Question 9, the first part is to integrate this expression here. I will start by writing it out so that I can actually move on with integration. So 3x plus 2 all squared over 4 root x dx. I will expand the numerator to give me 9x squared plus 12x plus 4 over 4x to the half dx. I will write this on a 10 by 10 basis, 9x squared over 4x to the half plus 12x over 4x to the half plus 4 over 4x to the half dx, which is 9 over 4x to the 3 over 2 plus 3x to the half plus x to the minus a half dx. And we're now ready to integrate. So it's gonna be 9 over 4. In integration, we increase the power by 1, dividing by the new power, plus 3x to the 3 over 2 over 3 over 2 plus x to the half over a half plus c. Do not forget the constant of integration. We've got some simplifications. The 2 with the 4 leaves me a 2. The 3 with the 3 go away. So this is 9 over 10 x to the 5 over 2 plus 2x to the 3 over 2 plus 2x to the half plus c. We had to give the answer in a simplified form. That's the final answer here. In II, we have an equation y is f of x. we are being given the form for the derivative. It's x squared plus ax plus b. We know that the y-intercept is -8. We know that the point 3, -2 lies on C, and the gradient of C at P is 2. And we need to find in its simplest form the expression for f of x. I will actually start by integrating to find an expression for f of x. So f of x is the integral of x squared plus ax plus b dx, which is x cubed over 3 plus ax squared over 2 plus bx plus c. We know that the y-intercept is -8, so f of 0 is -8, which means that -8 is simply c. We also know that we pass through the point 3, -2, which means that f of 3 is -2, and therefore -2 is 3 cubed over 3 plus 8 times 3 squared over 2 plus 3b, and the value of c, which was -8. So -2 is 9 plus 9a over 2 plus 3b minus 8. So 9 minus 8 is 1. I will take it to the other side. Minus 3 is 9a over 2 plus 3b. We also know that the gradient at x is 3 is 2. So in other words, f dash of 3 is 2. And we do have the expression for f dash of x. It was x squared plus ax plus b. So we get 2 is 9 plus 3a plus b. So minus 7 is 3a plus b. So we're essentially looking at two simultaneous equations, this one and this one. I will take this second one and multiply everything by 3 to get minus 21 is 9a plus 3b. So this is my first equation, this is my second equation, and I will just do this second minus the first. So minus 21 minus 3 is equal to 9a minus 9a over 2. And the 3b's cancel out. So minus 18 is 9a over 2, which means that minus 36 is 9a. So minus 4 is a. And I will now go back to this equation here to find the value of b. So minus 7 is 3 times minus 4 plus b. Minus 7 is negative 12 plus b. So 5 is b. And so I can now say that f of x is x cubed over 3 minus 4x squared over 2 plus 5x minus 8, which simplifies to x cubed over 3 minus 2x squared plus 5x minus 8.